All right, let's make sure the stream is up. Make sure the stream is up. Welcome, guys. Welcome. Make sure this is up. All right, let's make sure the stream is up. Okay, we are good. Just making sure that we need to let the Discord know. Oh, why not? Okay, just give it a little minute. Make sure, give time for people to jump in here. Gotta make sure the Discord knows. Okay. Okay. Maybe so we've reacted. All right. All right, guys. Welcome back to our stream. Today I'm going to be reacting to my mock coding interview that I done about 9 months ago, with YouTuber Ardman. I'm going to put his channel up here. I reached out to Connor when I wanted to first start making YouTube, and surprisingly enough, he actually replied, and he said he'd be down to help me out with the first video. He also made a video on his channel too. Probably be a good bit back, just over here, coding interview with a college student. So we're gonna be reacting to both. I don't know about both, but we're gonna be reacting to the interview that I posted on my channel with him. For some context, Connor is a ex-Facebook engineer. I think he has it in here. Yeah, ex-Facebook software engineer, and he's the creator of the front-end expert, which is a part of Algo Expert. And yeah, so let's actually get into it now. Gonna watch this back after work. See you tomorrow. All right, James. See you tomorrow. See you tomorrow. All right, let's get into it. I was actually pretty surprised. This actually got 13,000 views. Like, oh, anyways, yeah. Let's see. Hello, world. Today we're going to be doing a mock coding interview with a ex-Facebook engineer known as Connor Ardman. He also is the creator of the front-end expert aspect of Algo Expert. I really said "Hello world" at the beginning of this video. Wait, wait. Let me actually. I'm not letting that jump over. Hello, world. Like even the brig. You can tell I was nervous for this video, man. Ardman. He also is the creator of the front-end expert aspect of Algo Expert, and you can see a link to his YouTube channel right here. If just in case you guys don't know who I am, because this is my first video, I am a first-year computer science student in Dublin City University. Even the huge grasps of air, I was just talking so fast. Honestly, just so nervous, like, oh my god. And I'm also a incoming software engineering intern. Like, hello world is crazy. First video, like, what is this? I thought I was innovative. Anyways, HubSpot, which I'll be doing in summer. And I'm just using this channel to just share my experiences throughout my software engineering career. Obviously, I'm in my first year only, but I'm going to be sharing my experiences along the way, as well as try to give advice to some people that are just starting up, you know, just to get people onto their feet kind of thing. And yeah, I hope you guys enjoyed this video. If you want to see the part 1 of this video, will be on Connor Ardman's channel, and I will link the video down below in the description. And hope you guys enjoyed the video. Make sure to subscribe and like, and let's get into it.
Patrick, are you ready for your second question?
Before I actually go into this, like I just remember before going into this, I had a feeling he was about to ask me the hardest question in the world. I don't know, because this is like first time actually being interviewed by somebody from America. And I know in America, software engineering is, I was thinking, oh, a question that he thinks is, oh, medium level, intern level will just be really hard over here. So like, but actually wasn't too bad. Anyways,
yes, you know. Indeed. Let's see how this goes.
All right. So this question is called max subset sum. no adjacent, which I know is a bit of a mouthful, but the actual question's pretty straightforward. So we have a sample input, which is an array of integers. And what we want to do is return the maximum sum we can get by not using any adjacent numbers. So nothing that's touching each other. So here the answer is 330, which we get by doing 75 plus 120 plus 135. So those are the three numbers we use.
Like some more context on this, like at the point of me having this interview, it was like when I just finished learning dynamic programming, and then he just threw a dynamic programming question on my face. But like this one wasn't too bad. I actually remember seeing, as soon as I seen the question, I felt like, oh, this kind of sounded like the question house robber on LeetCode. So then like I kind of had like an idea of how I was gonna go about the question before I went into it.
And that's sort of the maximum we can get by not using any numbers that are next to each other in the array. Does that make sense?
Yeah, it does make sense. Yeah, okay. So we're just trying to see the maximum
Thanks,
maximum
next time.
sum, provided we don't choose any adjacent numbers. Yeah.
Yeah. So for example, if we want to use the number 120, we are not allowed to use 105 or 75.
Okay. And this is, will there always be a wait, sorry. Oh, we're just returning the maximum sum. Oh, okay. Okay, no problem. Yeah, so what jumps out to me immediately is, say we start at the 75. If we want to choose the 75 in our sum, we can choose that, and we can choose the maximum across so I'm going to call this recursively. So we choose the 75. If we choose 75, we choose the maximum from index 2 onwards. We call the function on that again, which is going to do the same thing. It's going to either choose the current as well as from index 2 onwards, or it ignores that current and just checks the index 1 onwards.
Here's me trying to act like I haven't seen this question before. Honestly, like I knew, I knew exactly how I was gonna solve this question before we even started talking. So now I'm just trying to act like, I'm trying to act like I have never seen the question before, but I have. I solved House Robber 1 and 2 before going into this question. I was like, bro.
Okay.
If you know what I'm saying. So that's what the function will do is, okay, for 75, we can either choose 75 and continue to add. So we're going to choose 75 and plus the obviously the max sum from the array from index 2 onwards, just skipping the adjacent number. And or we don't choose 75 and we just choose 105 onwards. And we run the same function on that. It's going to keep tracking the first number. We either go to this second onwards, or we ignore the first and we go from 1 onwards. Do you understand what I'm saying there?
Yeah, I think that makes sense.
Okay, so I'm gonna explain further as I code it up.
So I'm a scammer? No, I'm not a scammer. I didn't say anything. I didn't know the question at all before I came in here. This is a completely fresh question, trust me.
But the recursively, I think this is gonna be pretty bad in terms of time complexity, but I'm going to see how I'm going to memorize this as I go on. Okay, perfectly. So I guess our base cases, if our current index.
Well, let me ask you this before you start coding, actually. Do we... So I think what you described definitely makes sense. But I think it might simplify things a little bit. Do we necessarily... Well, I was going to say, do we need to do this recursively? And if the answer to that is no, it might actually, I think, help with what you mentioned of memorization. This definitely can be solved recursively, though, if that's the route you want to go. But I think
yeah.
Oh, go ahead.
Well, wherever there's a recursive approach, there's always some tabulation that I can do instead of the recursive just a recursive approach. But for now, I just want to go through with the recursive and then see how I can optimize in terms of space and time as I go on, if that's okay. Yeah,
that's fine.
Okay, so
honestly, part of me, like, while solving this question was like, I want to sound as smart as possible, so I'm just gonna throw out so many keywords like tabulation, top down, bottom up. What else was I saying? Yeah, just like I was just trying to throw out as many keywords as possible so that I can look good for the YouTube. But I mean, it worked out in the end. But I don't know if it was obvious that I was trying to just throw out keywords. But I guess throwing out keywords is good in an interview anyway. So
Presentation here is pretty okay. So
I think it's
now,
indented one time too far. So hold
yeah,
on.
it is. That's what I was thinking.
Yeah. So yeah, there you go.
Okay, perfect. So I guess one of the base cases is when if our array is nothing. So if say we're on index 135, then we try to call it on from an index that's out of bounds. So then it's just going to call the function with an empty array. It should. Yeah, it will just call the function with an empty array because we're trying to say array from index 0, 1, 2, 3, 4, from index 5, from index 6 onwards, or I think some 7 onwards, which will just be an empty array in Python. I think that would just give you an empty array if the index is out of bounds.
Yeah, I think
It
it
would,
does.
yeah, it would just give an empty array. So then, if it's an empty array, I'm just gonna return 0
W Python knowledge, guys. W Python knowledge.
because we can't take anything from obviously an empty array. So if not, we are going to return 0. And if we do have an array now, we're gonna return what we're gonna return is the max between if we were to choose the current number array, the first one. If we choose the first one, we add it to the max we can get from index 2 onwards, so skipping the adjacent one. So we're gonna see.
Tabulation is just using a DP table rather than recursion. So like we're using a DP table to map out the different decisions we're gonna make. And I think I don't know if I don't actually get into it with this problem, but tabulation is the process of using a DP table to like populate the state as you go along. Then you go iteratively rather than going recursively, which would be the recursive top down. But yeah, tabulation is just using a DP table instead.
This name is pretty long. Let me just copy it. Jeez.
It's a wordy one.
Yeah, array from the index 2 onwards. So we're skipping the adjacent one. So we're getting the max between that, and if we were to just get the max skipping the current index, the current first number, if we just skip that and just call it on the rest of the numbers, we get the max there because that could potentially be the max, and we return so we just call again on array from 1 onwards. So what this does, we either choose the current the first number, and we choose the max we can choose from the skipping the adjacent number, and or if we were to just choose, we were to skip that number and go with the rest of the array, that will return our maximum sum. Pretty sure.
Okay.
Yeah.
Cool. So let's get rid of this. I'll just delete this pass that was here. Cool.
I just have one thing. Sorry. I just thought of another edge case there. If the length of the array is 1.
Yep.
If the length of the array is 1, I just want to return that number straight away as well, instead of going into unnecessary 2 more calls.
I was honestly wondering if I was gonna account for that edge case. I forgot if I actually accounted for it, but well done, man.
Yep.
If that array equals 1, then we're just going to return array at 0. Just wanted to make sure. Is 135 is not considered adjacent to 75.
135. No, it is not.
Okay, cool.
Yeah, it doesn't loop around.
Okay, just wanted to make sure.
Honestly, so far I think I'm actually doing pretty well here. Like before jumping into the coding, I explained my approach and even went through the array with my mouse. I'm pretty sure he was able to see where I was highlighting and stuff. Went through all of that beforehand, discussed my approach with him. He proposed his own changes, and then I said, "Oh, okay, I'll use mine because of simplicity for now. I might optimize later." I was communicating actually very, very well here, to be honest, and this is surprising. I thought this was actually going to go a lot worse than it did. Obviously, I think this was after I was interviewing for HubSpot, so obviously I had done a lot of mock interviews with my friends, but I felt like the fact that I'm going to be on YouTube with somebody that has 200,000 subs, I was going to be a lot more nervous and then mess up. But I'm clarifying things very well, asking a lot of clarifying questions. With my recursion, I identified my base cases very well and my recursive cases very well. So honestly, fair play to me, to be honest.
Sure. Yeah.
Cool.
Yeah, I think that covers it. Yeah.
Cool. Do you want to? Let's maybe first test this with a few inputs, and then we can see about trying to optimize things.
Yeah, no problem. This is the okay. Let's say 10, 20, 40. And let me not get too big because then I won't be able to compute in my own head. 10. So here we could
It'll
either
tell
choose.
you what the expected output is as well. Whenever you run this, it'll run it with the correct solution as well. So it'll tell you.
Okay, code passed.
Yeah,
Well,
so
this one passed. I think let me just go with 100 now. And that was 1. Yeah. Perfect.
120, so 20 plus 100. Cool. Yeah, I think logically this makes sense.
Yeah, I solved this way too fast. I feel like he knew that. I think he definitely knew that I solved House Robber before. Just a little bit different House Robber. Honestly, the wording was doing a difference, but honestly, solved this one in like 8 minutes. Not even 8 minutes. I done a minute doing the intro. So like I solved this in like 7 minutes. It's like, but hey, let's see.
Now the time complexity. What are we thinking about this? And can we do anything to try to optimize things a little bit?
Oh, there's definitely something. I'm thinking what is dynamically changing here, which we can use to identify where we're running into another sort of problem we've already encountered. So say we choose 75. If we choose 75, we're going to run it on index 2 onwards. So we're going to be at 120. So that's going to run the function on 120, right? Cool. Now, if we were to ignore 75 and go to 105 and ignore 105 and go to 120, it's going to do the entire thing again on 120. Yes. So that's the sort of problem that we need to stop. So what we can cache is the current array. So I'm going to have a cache with the key being a tuple containing each element in the array, and the value being what the result was here. So like it would kind of be like a memo tuple, because you can't use arrays as the keys of a hash map. I'm pretty sure in Python you can't anyways. Tuple array is equal to, so it's going to calculate the max for that specific input.
So why do we need what is the tuple for again?
The tuple is, okay, so we're calling the function on this specific array holding, let's say here we called it on the 120 onwards. So it'll be holding 120, 75, 90, 135. So we've already cached the result for that specific array because we found the max that we can get from that specific array. So now when we go through again and we hit 120 again, the array is going to be the same as what's already in the cache, and we just return the result straight away. You know?
Right. So what if I'm not sure if this is specified in the problem or not. I don't think it is. So what if there were 2 copies of 120? So what if there was 75, 105, 120, 75? So see how we have 2 versions of 75? When we get to the second 75, are we going to have an issue there?
I don't know if I made it clear, but it kind of seemed to him like I was talking about I was going to store the number itself, but I was trying to store the entire array. I'm pretty sure I said array a few times, but he still thought I was trying to get the specific number. But I feel like he was trying to push me towards, instead of using storing the full array, I could just store the index, because there's absolutely no reason why I should use the full array when I could just store the index. Because I feel like that's what he was pushing me towards, but I think I eventually got to it.
You won't, because I'm keeping track of the whole array and not just the number.
Oh, I see. So it's so
I'm basically just,
I guess could you clarify what exactly is in the memo array? I might have misunderstood.
So the key is going to be essentially the inputs we're giving to the function. So for this specific array, it's going to calculate the max we can get for that specific subarray. I'm just going to say subarray. For that specific row subarray, we're going to get the max of that. We're going to store it in the cache. So if next time when we're going through our recursion, we encounter that specific subarray again, we're just going to return the max we already gotten instead of calling it again on the entire array. If you know what I'm saying?
Okay. Yeah, I think that makes sense. Let's see. Maybe try to implement it and we can.
Yeah, no problem. Okay, memo. And I think I'm gonna have to slap this whole thing into a helper function.
Okay.
How do I tab the entire thing?
Highlight it all and then hit the tab key.
Oh, it does that.
See, when I seen that, because this whole time I've been seeing people tab the whole thing. I was like, how are you actually doing that? I thought it was some revolutionary keyboard shortcut. Maybe you had to do 3 or 4 keys, and you just said, "Oh, just highlight it and press tab." I felt so stupid, honestly. I felt so damn stupid.
Yep.
Been a developer and I didn't even know that. Okay, def. Def. Just gonna say result. R. Just gonna change it up a little bit. I'm gonna call it on the whole array. Okay, call it on the whole array. If not R, and then we're gonna return memo at. Okay, I'm just gonna say inputs is equal to tuple R because I don't want to. What's it called? Call tuple like 3 different times. You know what I'm saying?
Okay.
So I'm gonna put that at the top. Right after the if not.
Also do shift tab if you want to go back. Yeah, I learned that one even further along the line. I think 5-6 months after this, I learned how to do to undo a tab as well. But yeah, I don't know why I just never learned that.
Array.
Honestly, I was in first year at the time, so I don't think anybody would have taught me that.
Yes. Sorry, right after this.
Yeah.
So I just went back to where I started. Okay, cool. So inputs, memo inputs, and then we're gonna return memo inputs. And I'm gonna change the name of this entire thing. Results. I think that is the whole memorization.
Result. Wait, what is What is
Yeah.
result? Online.
I made the whole function and just didn't even call it. Like, what the hell?
I didn't call it. Sorry, I didn't call it. Is that?
Yeah, honestly, learning that shift tab and tab thing, it just changes everything, makes things so much faster. Because I'd be there individually highlighting each line and pressing tab, highlight the next line and pressing tab. It's just so long.
That's the results name of the function. Okay, yeah.
Okay, results.
And then
hold on a second. So this is going to be in here, and then we're going to return the. Sorry, this thing just lagged. Then we're going to return this as a result. Yes, I think that's it.
Cool. And
if got the if statement, we need the if statement in there. If inputs in memo, return memo inputs.
All right. Yeah, I guess we need to use our memo for it to.
Yeah, just made it without using it.
Cool.
Okay.
Just making sure we don't have any other issues here. Tuple R inputs equals tuple R. Return memo inputs. Yeah. So we're just storing it in a cache before we return the result. Yeah.
Mm-hmm.
Then return result array. There was an issue. Is this indentation?
Output invalid syntax.
Oh,
I think you're missing the colon.
Look at me forgetting to put a colon after a function declaration. Oh my god.
Yeah.
Yeah. Test case 1 is passed.
Cool.
Okay, the code passed. And we're like, you're gonna run it on the whole thing?
Yeah, we can if you want. So if we go to tests and then run code, yeah, so it passes all the test cases. Cool. So let's talk about the time and space complexity of this version, and then there might be ways we can optimize a little more too.
Okay.
I remember I got the space complexity completely wrong. Wait, let's actually see it.
In terms of time, I'm gonna bring up a case here. Can I not see the cases, other cases, or can I only see my own
Yeah,
cases?
you can. So if we go to test and then you hit the little eyeball icon.
Oh. Okay. So, okay, let's say we process 75. We take 75 and we process everything for 120 onwards. Once we've processed 120 onwards, we have that result stored. So if you try to process 120 again, it's just going to return the result. So that will make the time complexity go down to linear time.
Okay, so essentially what you're saying is we are doing this like process step one time for each element in the array.
For each element layer, we are doing the process only once.
Okay, yeah. Yeah, I think that sounds right. Cool. And what about the space?
In terms of space, we are storing in our memo, we're storing the results of every output. So for every single input. So it will also be linear space as well.
Linear. Okay. Anyways, we'll see.
So what are the
Yeah.
It's honestly like going back to interviews that you done like a year ago. This is almost a year ago, and it just looked like, how did I think that this was linear? Kind of, it's just annoying. But
what are the keys and values in that?
Yeah.
Memo?
We are kind of holding every sub array. So let's say the key is the inputs and the value is the result that it gave. So in our hash map, we will have the entire array as well as no, not the entire array. We'll have the entire array as well as it cut down by 1, as well as it cut down by 1, as well as it cut down by 1. So it's kind of like so it is still linear space. Well, it would be like n plus n, I think it would be.
So
it would be n plus n, yeah.
how many entries are there in the hash map?
1, 2, 3, 4. In the hash map, we will have 1, 2, 3, 4, 5. We'll have 6 entries, 5 or 6.
Yeah. So, or with regard to n, that is roughly
that's
n, right?
So linear space, yeah.
So there's n entries in the hash map.
see, I'm still just so confident. Yes, it's linear space. Yes, it's linear space. Even though I'm storing every single subarray. I'm still thinking, yep, linear space. Jesus Christ.
For each entry, we have a key and a value, right? And what is the size of that key and value in the worst case?
Well, honestly, he did a really good job here in steering me, like telling me, okay, visualize it, and then maybe I'll get a better idea. So, he actually did a really good job there steering me.
The size of the key in the worst case is n as well.
Right. So if we have an array of size n, and each element in that array, or not array, sorry, if we have a hash map of size n, and each thing in that hash map has a potential worst size of n as well, then what would that give us, like, total?
And okay, the worst, it will have, the hash map will have everything. It will have n, then n minus 1, then n minus 3, n minus 4, n minus up until the 1. So right.
See, here I'm kind of like, okay, I'm definitely not right, if given the fact that he keeps on asking me questions. So now I'm trying to think, wait, where am I actually going wrong? But I think I still didn't get it.
I think it's still linear.
So,
but
when we have
could be wrong there.
Yeah, so one way to think about this hash map is almost it's almost like a nested array, right? Because it has size n, and each element of that, and each of the n things is also an array, right? Because they each have an array for a key. So if we have n arrays of size n, which, I mean, they are really size n minus 1 and minus 2, like you said, but time complexity wise, we just kind of look at the biggest one. It's going to end up being n times n, or it's going to be n elements in the hash map. Each of size n is going to give you n times n, or n squared, essentially, right?
Okay, so n squared space. Okay.
Right. So,
Okay, I
At
got.
this point, I don't think I actually understood it at this point.
I
and
understand
that's
what you're saying there.
because we have those.
Just have to act like, yeah, I understand what you're saying, but I don't. I think my head was still thinking, no, it's definitely linear. But given the fact that he's saying it's n squared, I'm just gonna say yes, so that he doesn't think I'm dumb.
Arrays in
Even though he probably already thought that I was dumb.
the hash map. So, sort of what I'm getting at is there a way to make our hash map or to have our memorization in general, regardless of how it's stored, is there a way to not have our memorization take up that much space? Like, do we need all of these arrays?
No, why am I moving like that? Honestly.
Oh, I guess I could just store indexes instead of the entire array.
Right.
That
bulb
that would be
moment.
the deciding factor, because so that would also account for duplicates, because obviously this first one will be 0. So for starting at index 0, we got this answer. For starting at index, you can't see me highlighting the test cases, can you? I'm
No,
just gonna copy it. I'll just copy it and just put it up there. Can you see me in the sandbox? Yeah.
are you in the which? Oh, you're in the sandbox.
Scratch pad.
Oh, scratch pad. Okay. Yeah, sorry, there's a lot of tabs. Okay. Yep.
Sorry. Okay, so for this 75, for index 0, we're gonna call the functions and we're gonna store that memo, yeah? So let's go a bit further down just to save time. Now we're at this 75. That index is not in the memo, so we're gonna call it and store the key being the index and the value being the results at that specific index. So then if we were to go again to 75, this index here will already be in the memo and we will just return the result straight away instead of calling the function. So I think that would work as well.
Okay.
So?
Cool. Can we maybe update the code to do that?
Okay. Updating the code. Because right now I'm kind of slicing the array.
Yeah. So right now you're like slicing the array,
Yeah,
but we already
slicing
have
the
that array, right? Like all that.
Okay. We have that array. Okay. I think it will be, let's say we're at this 120 here.
Yep.
That's index 01, that's index 2.
Yeah.
So the index will be so the index will be the length of the entire array minus the length of the current subarray.
The length
So
of the
entire array
Oh,
minus
yeah,
the current subarray, which will then give us the length of the first element there. Because in an array of length 6, the first index will be the length of the whole array minus the length of the whole array. So then in the subarray, the length of that subarray will be the length of the entire array minus the length of the subarray, which will then.
I honestly, if you gave me $1 for every time I said array, I think I'd be a millionaire. Like, why did I said array so many times there? So like me watching this right now, I have no idea what I'm talking about. I'm saying an array, and then I have an array, then I array the array, then goes to half the array, then use the array. Like, hello, what am I even saying? I don't even think you could keep track of what I was saying.
Which will then give us the index of the first element in that subarray.
Look at him, he's looking into the sky. He has no idea what I'm talking about. Not a single inkling, not a single doesn't know at all what I'm saying. What am I actually even saying?
Math makes sense?
I think so. I think
He thinks so. He knows it does not make sense.
you might be overcomplicating it a little bit. But I
A little
think what you
bit.
said is probably accurate.
Yeah.
But if
It's kind of, yep.
so, our subarray is always just a subarray from
So
some
it's such a
index to the
funny
end, right?
interview.
It's like on line 11, we do result array of 2 to the end and 1 to the end of it. So
See the way he's giving me air, like he's giving me space to just think. I still wasn't getting. Oh, what a messy interview.
do we need to be saving these whole arrays, or can we just save the index it started at, because it always goes to the end?
That is true. We could do that.
That is true. Like, oh, Jesus Christ.
We could do that. We are saving the entire array over and over again. Yeah. Yeah, we definitely could do that. So you're saying I just save indexes rather than the entire subarray. Because
Yeah.
we're gonna reach the end either way. Okay, yeah, we could do that. So I guess we can start this off with some sort of C, like kind of like a sorry, kind of like a cur. Then it's gonna be array. Oh, so cur. So we're just gonna call this on cur. So we're just gonna hold the index. It's gonna be the index, right? I'm just looping through if C is equal to len. I'm just gonna do this line by line to just correct it. If C is equal to the length of array minus 1, then we're gonna return array at 0 at C. Okay, that's as soon as we hit the end. Inputs, we're not gonna need this anymore. If C in memo, return memo C, and memo at the current index is equal to if we choose array at C plus if we were to call it on.
It's weird because like obviously as soon as he steered me, I'd know exactly how to do it, but I just wasn't getting these things that he was trying to steer me to until he kind of explicitly said it. So like it wasn't entirely bad because I was able to implement it pretty fast. I was able to understand it pretty fast, but I feel like the fact that I didn't get it like immediately would obviously dock me some marks in like the whole hiring process if this is a real interview.
The current index plus 2. Exactly. Let's call on the current index plus 2, or we just call it on C plus 1. We return memo C and call that on 0. I think so. And if not array, which would just be if C equals 0. Then return. Wait, no, not if C equals 0. Sorry.
I was about to say.
If not C, if C is equal to len array minus 1, if C is greater than len array, then we just return 0.
Okay.
I think that covers it. So the first, if C is greater than len array, that's covering if we go out of bounds. If C is equal to len array minus 1, that's covering if we're at the last element. We return array at C. If C is in the memo, we've already calculated for that index. We return memo at C, and we store. If not, we store memo at C equal to the max. If we were to choose the current array at the current number at array C, plus if we were to call the function on the current index plus 2 to ignore the adjacent cell, or we just call the function on every index after ignoring the current number. Does that make sense to you?
Yeah, I think so. You want to run it, make sure it still works?
Ooh.
Okay.
So
Sticky.
I remember as soon as I saw this, my heart dropped to the floor. I was like, whoa.
So maybe if we look at, it looks like we're having a runtime error. So if you look at test case 1 and open it up, it says list
1.
index out of range on line.
Yeah, because I had if C greater than len array and not if C greater than or equal to len array. That was my issue.
12? Or sorry.
I can't see the line 10. Is that what it says? Line 10.
Memo. So it's it's the line where you're creating the. Oh, so I see. Line. It looks like results of 0. Oh, so at the end. Oh, I see. Sorry, you're calling result of 0, and then where is the index out of range?
How do we not find it? It literally says it right there. Memo C is equal to max in array C plus result C plus 2. How did we not see this straight away? Honestly, I have no idea.
A little bit of debugging here. Hold on. Using max array C plus result C plus 2 plus result. Yeah. I thought I took care of if the index is out of range already.
So where is?
Oh. Sorry.
Oh, go ahead.
Oh no, I was just thinking if the array was empty, C would not be greater than the length of the array.
Yes.
C would not be equal to that. C would not be, and then it would try to access array C. So okay, floor array.
Top debugger, guys. Top debugger right here.
Okay, what were you gonna say? I don't think that covers it. But
Yes,
what were you gonna say?
yes, I don't think that's going to solve the main issue because like this is failing on most of them.
Mm-hmm.
So,
So I identified the issue, but I didn't actually apply the right fix, bro. Like I literally said, okay, the problem is we're checking. Oh, C is greater. If C is equal to then array, then we go down, and I didn't even see the fact that I wasn't checking if C is equal to then array.
do not spend a whole lot of time with Python. So I'm trying to understand this list index out of range. So that's the first thing is to see where is list index being used. Program.py line.
Oh, if C is greater than or equal to, or equal to then array. I think that should solve it.
Okay.
We're running out. Yeah. That's perfect.
Okay. Yep. There you go.
It's a minor thing.
Oh, finally.
Okay, that's
Cool.
amazing. This brings it down to constant space rather than squared space.
Okay. So
And still linear time.
Constant space, even though I'm calling the recursive function on every nice.
Sorry, not constant space. Sorry, linear space.
Okay, at least you caught it right
And
after.
linear
Oh, good.
time.
all right, cool. So I think this is correct. One small follow-up question. With our memo, since we changed it to the key is now an index, right?
Mm-hmm.
So do we need a hash map necessarily? Or could it be a simpler data structure? And it won't necessarily
There's
change
that
the
again.
complexity analysis.
It could just be an array. Yeah.
Yeah.
We could just use an array and then like index 1. So then it would be array index 1 would be equal to the max, and then if C, so then we'll have like if array at C is not equal to some number, like I start off with like -1. If array at C is not equal to -1, meaning that we've already processed that thing, we've already processed that specific index onwards, we would just return that number in the array.
Yes. So I don't actually think anything necessarily needs to change in the code other than it can just be made into an array, right? Because the
I was thinking that it's the same as JavaScript, because obviously in JavaScript you can just set memo, like you could just set something at array index 1000 when your array is only index 10, and you wouldn't get an index out of range error. It's a weird thing about JavaScript, but Python obviously cannot do that.
currently you have a hash map where the key is the index.
Yeah,
and that index is going to be anywhere from 0 to the length of the array, right?
So are you trying to say if I was to just change the brackets here like this?
Yeah, I think it can simplify things a little bit.
Yeah, the thing
To me, I'm smiling so hard because I'm just about to prove him wrong. I don't know why I was so excited to prove him wrong that Python can't do this.
is can't do that in Python.
You can't?
I know in JavaScript you can, it will dynamically, but in Python you can't change an index that's not there yet.
Oh, so yeah, I guess you would have to create an array of some size, right?
Yeah, -1 for I in range an array.
Yeah. Yeah, and I guess maybe you can make an argument that that's not actually simpler in Python land, but generally I think using an array over a hash map is maybe a somewhat better, but I guess either way is fine.
Yeah, I understand. Yeah, it's so.
And then also, I don't know if you need that check above memo. It's not really hurting anything, but
yeah, exactly. Okay.
Yeah,
that's perfect right there.
Cool, awesome. I can give you a little bit of feedback if you want it.
Okay, before we get into the feedback, obviously, I'm trying to say how I feel about this interview. Obviously, looking back at it now, it's like I feel like I've done well in terms of collaboration, and like I talked about my code before I wrote it, type of thing. I was collaborating very well. I was leaving room for the interviewer to speak to me, try to guide me and things like that. So I think I was good in that aspect, as well as while I was coding, I was just talking through everything, which was really good. Explaining my approach before I started coding. And discussing time and space as well. Obviously, I feel like the only issue was when I was being steered, I wouldn't get it straight away. But like obviously that's not going to be a groundbreaking issue, which would say, oh yeah, don't hire him. But it's more somebody that as soon as they got steered, they were like, oh okay, I understand, and then they explained it. They would get it over me, which took a bit longer. Like with the explaining the space complexity, explaining why it was n squared, like that took way too long. Honestly, that took way too long, and depending on the level of engineer that I was interviewing for, that could be a failing mark. The fact that I couldn't analyze the space complexity incorrectly, and as well as being steered, it took me about 5 to 10 minutes to actually understand it. So like apart from that, I think I was doing very well in collaboration coding, and as soon as I got it, I implemented very fast. So it's obvious that I have a great understanding of how these things like recursion works, how Python obviously works in coding. So it's obvious that I code a lot in this interview. And so yeah, I think if it was an internship level, I'd get a higher. New grad, maybe higher, depending on how everybody else was. Anything above new grad, I don't think I would have gotten it, honestly.
And we can talk about this question and the one we did on my channel if you want. So, and to be clear to like people watching, usually at the end of an interview, you usually don't get much feedback, but I think it can be helpful. So I think you did a good job. I definitely would have passed you in this interview, especially if it was for like an internship type position. With this problem specifically, your answer was correct, and it works. On like the code itself, one thing I would avoid doing is using variable names like C, because
that was another thing I thought was terrible. Like, why did I actually choose C? I think I was just trying to code really fast, but that alone can trip off an interview, honestly.
they're just kind of confusing. So
Yeah.
the only single letter variable name I would really ever use is I. And maybe this one even should have been called I because it's an index, right?
Yeah, true.
So I would avoid that. And like in the other problem, I think we used L and R for left and right. And that can be fine because I think those along with I are pretty obvious. But ones like C, I would, if it's meant to be cur, I just write that out. The first question I think you had basically completely correct. This one is correct. There's one follow-up I was considering asking, and I chose not to because I think it would be too big of a change to do it. But there is actually a solution to this problem that uses ov1 space with the same time complexity. And essentially what it requires is rather than doing this recursively, we would generate our memo. Oftentimes can
pretty sure he showed the code for this. Let's just check real quick. Yeah. Right here I seen, if not, anyway, maximums I is equal to max teen, array 0 and array 1, maximums I is equal to max 15, maximums I minus 1. I mean, so ov time and ov space. This is not the ov1 space solution. What key shows? Obviously, it's like this one here. Oh yeah, where you just and then just update it iteratively. That's just the weird thing about these DP problems. Is almost always a way where you could just use 2 or 3 variables and then just keep track of it. But it does increase the complexity of your solution a lot. Like it just requires a lot more thinking. So like obviously this didn't jump out to me straight away because it just didn't jump out to me straight away. There's no because it just didn't jump out to me straight away, honestly. Obviously O time, O space may be good enough for new grad internship, but if they're looking at a senior type of engineer, they might be expecting them to go down to the O1 space type of solution. But like the O1 space solution actually makes sense when you actually look at it for long enough anyways. Well yeah, honestly, interview was good.
What was the
in my opinion? Obviously the rest of this is just talking about that solution. But yeah, honestly, for the first video, it has done pretty well. 13K views 9 months ago. Not bad at all. I was pretty nervous. I don't know if it was obvious at all, but I was pretty nervous for going into this interview. But I'm happy that I was able to have my first video with somebody that had over 200,000 followers. So yeah, man. Anyways, yeah, I think I'm gonna end the stream now. I'll be back next week, Friday, same time, 8 p.m.